Good day. Welcome back to our YouTube channel, and if you're new here, welcome. This is where you belong. So if you haven't subscribed, please subscribe, as this will help us to keep on creating more content for you, and also it will help you to keep on learning, right? So today we are on the topic alkyl halides. So we are going to discuss what are alkyl halides, and then from then we'll also talk about the aldehydes and the ketones. So you are welcome. Please enjoy this as much as I'm also enjoying doing my work. So what are alkyl halides? So alkyl halides are the hydrocarbons that are having at least one halogen. So they're having at least one halogen. And already we have talked about halogens and how much they only create one bond. So these halogens that we are going to talk about, they are fluorine, chlorine, bromine, and also iodine. So these are the halogens that we are going to talk about. So alkyl halides, as I indicated there, they are also called the haloalkanes. They are also called the haloalkanes, and their functional group. So their functional group, it is this with this X representing a halogen, right? So the X is representing a halogen. It's either fluorine, chlorine, bromine, or iodine. So we are going to talk about how you can name these hydrocarbons, right? We are going to talk about how we can name them. So as we said, they belong under the homologous series of what? So their homologous series, it is the alkyl halides, or we can say haloalkane, right? So now let's focus on naming these hydrocarbons. So we are here. How do we name haloalkanes? So these are the rules that can help you to name haloalkanes, right? So the first step, always to identify the longest carbon chain, which is called the parent chain. And this parent chain, you must also include the carbon atom that is carrying the halogen. So in the longest chain, you must include the carbon atom that is carrying the halogen, right? So after that, the second step is to name the parent chain as if naming the alkanes. So it means that if there are 3 carbons in the chain, it will be propane. If there are 4, it will be butane. If there are 6, it will be hexane, and so on, right? And then after that, you number your carbon atoms from the side closest to the carbon that is carrying the halogen. So you must always check where your halogen is, and when numbering your carbon atoms, you must start from that side that is closest to the carbon that is carrying the halogen. And then from then, name the halogens as follows. If you're having a fluorine, then you name it fluoro with its number, right? On when it is coming, that carbon number, right? And then when it is chlorine, you name it chloro, like that. If it is bromine, you name it bromo. And if it is iodine, you name it iodo, just like that, And if there are 2 or more halogens of the same type, we use these prefixes di, tri, or tetra if there are 4, right? So if there are 3, it's tri. If there are 2, it's di. Just for an example, if you're having 2 chlorines, so it will be dichloro, right? Dichloro, just like that, right? And if there are 3, it will be trichloro, right? Just like that. And then lastly, when writing your full name now, start with the one that comes first alphabetically, right? So it is quite obvious that B comes before C, and also C comes before F, and also F comes before I. So it means that you first name the bromo, then the chloro, the fluoro, then lastly the iodo, right? So always remember to put the number on which that halogen is situated, right? So if it is situated on carbon number 2, then you include 2 fluoro, then you name the name, right? So now we are just going to go through a couple of examples, and we'll see how we can name that, right? And also remember, just like we were dealing with branched alkenes, it means that also on this case, also the functional group, because this is the functional group. So it means that the halogen is more important than the branch, if they are branches. So it is more important than the branch. So we first prioritize the halogen. So it means that we are numbering our carbon atoms from the side that is closest to the halogen than the side that is closest to the branch, right? So it means that the halogen is more important than the branch, right? And also, if you're having 2 of these different halogens coming at the same number from opposite ends, it means that we first prioritize the one that comes first alphabetical. So it means that B, if B is on carbon number 2 from this side, and also chlorine is, Br, and also chlorine is on carbon number 2 from that side, so obviously the B comes first before the C. So we prioritize the B first before the C, so on and so on. So also the F is prioritized more than the I, just like that, just like that. So just copy this or make a screenshot, and then we can go over how to name this with examples now, right? So let's try this out. So we are having 2 molecules there to try to name, right? So on this first one, we first check how many carbons we're having in the longest chain. So we're only having this chain. So how many carbons? 1, 2, 3, 4, 5. So the parent name here is going to be a pentane as our longest chain, right? And then we check our halogen, right? So our halogen is the chlorine there, right? So we number our carbon atoms from the side that is closest to that. So it's quite obvious that it is closest to this side. So let's number our carbon atoms. So 1, 2, 3, 4, 5. So on carbon number 2, chlorine is coming. So I've already shown you how to name these halogens. So on carbon number 2, we are having a chloro, right? So on carbon number 2, we are having a chloro. So now how to put this name together, because now we don't have another halogen there. So it means that we are only having one halogen. So to name this, we start with the what? With this halogen. So our final name now, we are going to combine the 2. So this is 2 chloropentane, 2 chloropentane, like that. So let's move on to the next one. If you want to try this before I can do this, you can pause the video and work on it, and I'll give you the answer in 3, 2, 1, go. So naming this one, obviously we start to check our longest chain. So this is just a continuous chain like that. So it means that we don't have any branch here, right? So this is a continuous chain. And how many carbons do you have there? 1, 2, 3, 4, 5, 6. So we're having 6, which means that this is a hexane, like that, if we're having 6 carbons. So now we number our carbon atoms from the side that is closest to the halogen there. So it means that we are going to count from this side 1, 2, 3, 4, 5, and 6. So now let's see the type of branches that we are having. So we are having this chloro that is coming on carbon number 2, and we are also having this bromo that is coming on carbon number 3. So let's indicate. So on carbon number 2 we are having a chloro, and on carbon number 3 we are having a bromo, right? So now how do we name this? Remember that we said the B comes before C in the alphabet, right? So it means that we are going to start with this bromo one. So this is 3 bromo, and always remember that between letters and numbers we put a hyphen. And also we are going to name this also, which is 2 chloro, then the parent chain now hexane, like that. So that is our full name, 3 bromo 2 chlorohexane, just like that, right? So maybe let's try out one more before we move on to aldehydes and ketones. So let's check this out. So you can also try to do this, and I'll resume the video in 3, 2, 1, go. So first step, we said we identify the longest chain. So the longest chain, it is just this chain with 1, 2, 3, 4, 5 carbons. So 5 carbons, this is a pentane, right? 5 carbons, it's a pentane. So what's the next step? The next step, we identify our halogens. So we are having this halogen, that halogen, and also that halogen, right? Now we are going to number our carbon atoms from the side closest to that halogen. So if we count from this is 1, 2. This is coming on carbon number 2. And if we count from that side, it's also 1, 2, and it's coming on carbon number 2. But remember that we said we are prioritizing alphabetically now if they are coming on the same position. So they're coming on the same positions from different ends. So B comes before C. So it means that we are going to number our carbon atoms from this side because it is closest to B. So that will be 1, 2, 3, 4, 5, right? So now we give the number where our halogens are coming. So on carbon number 2, we see that we are having a bromo, right? And on carbon number 3 and number 4, we are having a chloro. So that will be 3, 4. We said if there are 2, we use this. So this will be dichloro. That will be dichloro, right? Because there are 2, we use di, right? So now how do we put the whole name together now? So we are starting with the alphabet. So this will be 2 bromo, right? And before we can put a number, we put a hyphen. So that will be 3, 4, because we said between numbers we put a comma, right? And a hyphen, dichloro, and then the parent name, pentane. The parent name, pentane. So this will be our name for this compound, just like that, as easy like that. So it means that now let's go on to aldehydes and ketone, and then we'll be done for the day, right? I hope you still got the energy. So now we are on aldehydes and ketones. So these aldehyde and ketones, these are organic compounds. These are organic compounds that contains a carbon oxygen double bond. So they contain a carbon and oxygen double bond. So they contain a double bond between the carbon and the oxygen, right? So this is their functional group. So the ketones and the aldehydes, they have the same functional group, which is and a double bond between oxygen and carbon, like that. So this functional group has a name. So this is called the carbonyl group. This double bond and the carbon between carbon and oxygen is called the carbonyl functional group. So this is the functional group of both the aldehydes and the ketone. So we are going to see the difference between the aldehydes and the ketones, and also when it comes to naming, right? So we'll start with the aldehyde first, then we move to the ketone, and then we'll see how we can name that, but it is very simple, right? Aldehyde. So how do we name the aldehyde? As you can see, in the aldehyde, this functional group is always at the end of the long chain. That's why we write it like that. It's at the end of the longest chain. So as I said, this carbonyl in aldehyde, this carbonyl functional group is always placed at the end of the what? Of the chain. So it is always placed at the end of the chain, and we write it like that, right? So to name now the aldehydes, so when you come to naming the aldehydes, so what we do, we identify the longest chain. So we identify the longest chain. But since we say that this functional group is always at the end of the chain, so there's no need to number, because you always know that it's always at the end. And the next thing now, after identify the longest chain, what we do now, we write the name of that longest chain. So we write the name of that longest chain as if we naming the alkanes, as if we are naming the alkanes. But now what we do now, we replace that E at the end of the chain. So we replace that E at the alkane name with the al. So this al shows that this is falling under aldehydes. So that al represents that this is the aldehyde. So maybe let's take a few examples on naming, and also we can draw a couple of these aldehydes, right, with these simple rules that we have placed. So remember that the functional group is always at the end of the chain, right? At the end of the chain. So let's see. So let's see using this. So we can see here our longest chain is having 1, 2, 3, 4 carbons, right? So if these were the alkanes, we're going to name this butane, right? But now we said we are going to replace this E with what? With Al. So replace it with the suffix Al. So this compound now becomes butanal. So this is a butanal now. So naming this, do you want to try? So I'll give you the solution in 3, 2, 1, go. So also here we can see that this is at the end of the chain. So how many carbons do we have? 1, 2, 3, 4, 5, 6. So we name it as if we're naming the alkane, right? Which is the hexane, right? But now replace that end E with Al, and we have hexanal, like that. We have the hexanal. So to make this simple, so it means that if we are only having one carbon, it will become the what? Methanal. If there are two, that will be ethanal. If there are three, then that will be propanal. And we already talked about 4. If there are 5 now, so this is 1, 2, 3, this is 4, this is 6. So if there are 5 carbons, that will be pentanal. If there are 7, that will be heptanal. If there are 8 carbons, that will be octanal, like that, right? As simple as that. So it means that this is way simple and straightforward. You can be able to identify this, right? So now I'll go to ketones. So with the ketone, as you saw, like I wrote the big O in between. So to represent how these ketones actually are, right? So the ketones, they have this carbonyl. They have this carbonyl placed at a position within the carbon chain. So now this carbonyl is no longer at the end like in aldehydes, right? Now it is somewhere within the longest chain. So the carbon carrying this is not at the end, but it is placed somewhere in between the carbon chain, right? And its functional group is shown in this way to represent another chain that is coming that way and another chain that is going that way. So it's not at the end, it's somewhere within, right? So now, how do we name this? So how do we name the ketones? So naming the ketones is also easy. So what we do, the first is to identify. So we always have to identify the parent chain first. So we identify the parent chain. So the longest chain that is carrying the carbonyl. So the longest chain must always carry that carbonyl there, right? So after that, we write the name. So we write the name of the longest chain, just like writing the alkane. So just like we are writing the alkane, but now we replace that E at the end of the alkane with O-N-E. Now we replace it with O-N-E, just like that, right? Just for an example, if it is having 3 carbons, then that will be propa, as if we're saying propane, but now we replace it with 1, like that, right? So notice that if we're having 3 carbons, obviously it will come on carbon number 2, right? So there's no need to number that. If it is 4 carbons, also there's no need to number, because so this will be butanal. So if there are 4 carbons, obviously it means that either way it will come on carbon number 2 if you count from this side, or if it is there, we'll also count from this side. So there's no need to number. But however, if we're having 5 carbons or more now, if we're having 5 carbons or more now the position matters, right? So it means that we are going to number our carbon atoms. So we're going to number carbon atoms from the side closest to the carbonyl, right? And also include the number in the name. So I'm going to show you how do I mean this, right? Numbering the carbon and including it in the name. So let's try to name these ones with 5 carbons or more, right? So firstly, we identify the longest chain, which is 1, 2, 3, 4, 5. This is what's supposed to be a pentan, right? So we don't include the E, right? Now we number the carbons from the side closest to this. So if we count from that side, is 1, 2, 3. From that side, it's 1, 2, 3. So either way, it is still 3, right? It's still coming on carbon number 3. So on carbon number 3, that's when we are having a what? Like that, right? That's when we are having the one like that, the ketone. This one is representing the ketone, right? So putting together the name, we are going to first start with the parent. So the pentan, and then 3, 1, like that. So pentan, 3, 1, just like that. So this representing the parent name, and this representing the position where the 1 is coming. The 1, it is the what? The carbonyl group. So it's coming on carbon number 3. So when naming the ketones, then numbering is important, mostly from 5 carbons and more. And on aldehydes, numbering is not important, since the functional group is always at the end of the chain. So let's do the last one. So if you want to try it, you can pause the video and I'll give you the solution in 3, 2, 1, go. So also with this one, so let's check how many carbons we have in the longest chain. It's 1, 2, 3, 4, 5, 6, 7. So if we're naming this, it's a heptan and not include the E, right? And now we number our carbons from the side closest to the what? To this carbonyl. So obviously it is closest to this side. So it's 1, 2, 3, 4, 5, 6, 7. So this is coming on carbon number 2. So on carbon number 2, we're having the 1 like that, the ketone, right? So how do you put the name together? We first start with the parent name. So this is heptan, then 2 representing the position, then 1 representing that this is a ketone. Just like that. As simple as A, B, C. Yes. So that's how we name the ketones, right? That's how we name the ketones. So having done this, it means that the next time we meet, we are going to talk about the alcohols. And then if there's still time, we can also talk about the carboxylic acids on the same video, right? I hope you enjoyed as much as I did. Please don't forget to like, subscribe, and share. So just remember that these 3 things, liking, subscribing, and sharing, helps us a lot, right? So it is absolutely free to subscribe, to like, and to share. If you really enjoyed this and you really want us to keep on pushing this content, please, 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 with 2 hands, please, 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 just subscribe, like, and share. So I'll see you on the next one. Enjoy the rest of the day.